In this episode, Sasha and Keoni turned to a different set of 3 other points that they had found in Lesson 6. 2, 4 for the red parabola, 2.8, 4 for the blue parabola, and 4, 4 for the green parabola. Notice how these points share the same y value of 4. They use these points to generate another explanation for why increasing the p-value results in the parabola getting wider on the coordinate grid. Try generating an explanation on your own first. When you've finished, resume the video so you can compare your argument with Sasha and Keoni's.
Now here's a clean version of the 3 parabolas again. And do you remember finding these 3 points? 2, 4 for the red one.
Oh yeah, because we wanted to have a consistent y too.
Yeah. So now you have a consistent y. What is it?
4.
And can you use these points to, again, give us even a deeper understanding of why when you're increasing p, the parabola's getting wider?
Okay, so we,
As the p increases, the x increases as well. Can you see that?
yes, totally.
Okay, cool.
Okay, so you can see like the x is 2 here, and then it's getting greater as the p is increasing. Your x was also getting wider.
Yeah, and why, if the x is getting bigger, why does that force the parabola wider?
Because your
Because
x-axis
x's go out
is
that
the
way.
horizontal line.
There you go. Pick another point that has an even bigger x value but the same y.
Right here.
Will that force that parabola to be wider?
Is that 4.5? I'm going to say that's 4.5.
Yeah.
4.5, comma 4. And it forces it to be wider.
Uh-huh. And if you had a x value that was less than 2?
Then it would be skinnier.
So like 1, right?
Yeah.
1, comma 4.
Is skinnier than the rest of them.
Keoni noticed that as the p-value increases from 1/4 for the red parabola to 1/2 for the blue parabola and then to 1 for the green parabola, the x values of the 3 points that share a y value of 4 increase from 2 to 2.8 to 4. Keoni went on to explain that this means the parabola gets wider because the x's go out. Sasha added that it's because the x-axis is the horizontal line. They are referring to the fact that the x value in the point x, y controls the horizontal component of that point. Notice how the point 2, 4 on the red parabola is 2 units to the right of the y-axis. As the x value of the point increases to 2.8 for the blue parabola, the point stays along the horizontal line at y equals 4. But, as Keoni put it, it goes farther out, which forces the parabola to be wider. If the x value of a point is increased, but the y value is the same, then the distance between the y-axis and that point is greater, thus forcing the parabola to become wider. Next, Sasha and Keoni use the general equation y equals x squared divided by 4 times p to explain why increasing p increases the x value of the point when y equals 4. Try to make this argument on your own first. When you are done, start the video again so you can compare your explanation to Sasha and Keoni's.
Now, can you use that general equation and put 4 in for the y and kind of see what's happening with what's going on as we
4
increase?
equals x squared over 4p.
Yeah, so what's happening as we increase p? And you might want to get it in as simplest form as you can.
Okay, what else can we do here? We can
Get rid of the 4.
get rid of the 4 by...
Times by 4.
Yeah, go ahead.
25 times by 4. 16 equals x squared over p.
Now, as p increases, what happens?
Wait. The x increases
How do you know?
because...
We so lovely graphed it right here.
Can you see it from the algebra?
No, yes.
If you can't,
Yeah.
you might want to use the other form of the algebra. Do you remember how when we used to, Sasha was always very good at converting the y equals x squared divided by 4p
Oh, like the square root and all that?
Yeah,
Oh,
so that you
okay.
got x equals something.
Okay, so then the square root of the whole thing or just of x?
I would get it
Just
as simple as you can.
Okay.
You can either do it here or you can do it over in general and then put the y in.
Okay. How do you do that?
Like,
do you
do it
want-
here first.
Sure.
And then, okay, so do it here first.
You
So-
do it.
So get
So
x by itself.
Get x by itself.
Want to just times by 4p?
No, because we have to get rid of the.
Yeah, but then it's easier when it's like not a fraction.
So you want to get rid of it first. Okay.
All right, so times by 4p.
So it was, what was it? It was
So instead of times
4y
by
over x squared over p. Right? Because you're multiplying 4.
yeah, and then times by p again, right? Do you want to just times it by 4?
You're multiplying it by
4p.
p again. Okay, so 4 py
Equals x squared.
and then square root it.
What do you have?
Get that x equals square root of 4
Py.
py.
Now, in this case, what is y when we're looking across there at all those points?
4.
Okay, put that in.
X equals square root of
We
4.
were writing all over our graph.
It was 4 p.
So x equals,
X equals square root of 16p.
which it would be like,
You can make it just a little simpler.
X equals 4p.
Don't forget the square
Square
root
root
of
of p.
There you go. Now, what happens as p increases?
X increases.
How do you know that? Can you see it now?
yeah, because you're going to times whatever that p is by 4 after you take the square root of it.
That looks, yeah, you can
there
see
we
it
go.
now.
Yeah,
Yep. And
yeah, that's easy.
as x is getting bigger, what's happening to the parabola?
It's getting,
It's getting
wider.
wider.
Because it forces it out.
Yeah.
Okay, so now you've got two insights as to why this is happening. And now guess what we're going to return to?
What?
The special points.
Okay,
Okay.
okay, we like the special.
We like the special.
That's
We
not so
all love
bad.
the special points.
Sasha and Keoni used the fact that the 3 points share a y value of 4. They substituted 4 into the general equation for y. But their goal was to explain why increasing p would increase x, and thus make the parabola wider. It was hard to see in this form, so they started over with y equals x squared divided by 4 times p, and solved for x. Once they had x equals the square root of the product of 4 times p times y, then they let y equal 4. Keoni said he could see that as p increases, x also increases. Sasha agreed, arguing that as p gets bigger, the square root of p will also get bigger, and then you multiply it by 4 to get x. So, as p increases, the x value increases. Earlier in this episode, Sasha and Keoni figured out that as the x value increases while y remains fixed, then the parabola gets wider. Putting these ideas together, they have offered another way to understand why, as p increases, the parabola gets wider.